Alright, so today's video we're going to look at average versus instantaneous acceleration. So we'll start by looking at the average acceleration, which will just be the change in instantaneous velocity divided by the change in time. So we can write this as an equation where we have acceleration equal to change in Vx over change in time, where AVx is the average acceleration of an object in the x direction, and then change in Vx is the change in the instantaneous velocity in the x direction, and then change in t is just change in time. And then a more useful way to write this equation is average acceleration equal to v at x2 minus v at x1 over t2 minus t1, where vx1 is the instantaneous velocity at position x1, and then vx2 is the instantaneous velocity at position x2. Now, one useful note, just don't confuse velocity with acceleration. Velocity tells us how fast and in what direction an object moves, while acceleration simply tells us how the velocity changes in time, so how the speed or the direction of the motion changes. Now we can look at instantaneous acceleration. So to define instantaneous acceleration, let's suppose a car is driving down a street. So to illustrate this motion, we can draw the car moving from point 1 to point 2, where v1x is the velocity in the x at point 1, and then v2x is the velocity in x at p2, where x is just the position. So now we can define the instantaneous acceleration as the limit as delta t goes to 0 of the change in the velocity in the x divided by change in time. So note that change in Vx over change in time is just the average acceleration. So we're taking the limit as the average acceleration goes to 0. So this interval is just getting smaller and smaller so that the average acceleration just turns into the instantaneous acceleration. And the calculus version of this equation is the instantaneous acceleration is the change in the instantaneous velocity divided by change in time. And this is useful when they give us an equation for the instantaneous velocity.